Hey guys, Josh McKay from the Test Experts, continuing our series on calculus. We've done a couple videos now telling you how to do derivatives. Now we want to talk to you about what is the purpose of derivatives or why are they valuable. Remember, fundamentally a derivative is a slope of the line. It's a way to find a slope of a complicated line. So what use is the slope of a line? It tells us whether a function is increasing or decreasing. So one of the uses of the first derivative is to tell whether a line's increasing or decreasing, or find the intervals over which a function is increasing or decreasing. Now in this example that we're going to do, we've got the derivatives already given to us. G prime of x is negative 2/3 cosine x sine of x, and then they've asked us only to do it over this interval from 0 to 2 pi. So how do we do this? How do we figure out if it's increasing or decreasing over this interval? Just plug in values for x to the derivative and see what they are. So if I plug in, say, a value in this interval between 0 and pi over 2, I will get, so I can pick like pi over 4. If I plug pi over 4 in here, I will get a negative number, and so this is a negative interval, which means the slope is decreasing, the function is decreasing over from 0 to pi over 2. And then in general, it's going to switch back and forth. So once I've done one, I can then just go ahead and assume that it alternates. But you could plug in, 3 pi over 4 and 5 pi over 4 into this just to be sure, double check your answers until you are sure about the pattern. Okay. So how did we get these values in the first place? It's pi over 2, pi, 3 pi over 2, and 2 pi. Well, obviously 0, but how did I get these values? How did I know it's switching? How did I know these were the intervals? That's all about finding the maxes and mins. One way we can do that is set this equal to 0. So where does the derivative equal 0? That would mean the slope is 0, and going back to our algebra, a 0 slope is a horizontal line. So that would mean that if the slope's horizontal, it's switching from going up to down or down to up. So if I plugged 0 in for g prime of x and solved this, I could see anywhere that cosine x or sine x is 0, this whole function would be 0. And those places are pi over 2, pi, 3 pi over 2, and 2 pi. So we know how to find the maxes and mins. We know how to find the increase and decreasing. How do I know whether it is a maximum or a minimum? I know that pi over 2 is either a maximum or a minimum, but how do I know which one? A couple ways. If I have the original function, which in this case I don't, but if I do, I can always just plug in pi over 2 and pi and 3 pi over 2. The big ones are going to be maxes and the small ones are going to be mins. In this case, though, what I can do is think about it logically. If I'm decreasing over the interval from 0 to pi over 2, and then I'm increasing after that, the original function now is decreasing here from 0 to pi over 2, and it's increasing after pi over 2, then that clearly must be a minimum. So I know that pi over 2 is a minimum. Pi then, and again, just like before, these are going to alternate, but you can see if it goes from positive to negative, this was increasing slope, and suddenly it's decreasing, then that must be a maximum. And so that one will be a minimum. And you don't have to find the ones on the end usually, but we could go ahead, we know that that one's going to be a max, and that one will also be a max because it's going to continue to alternate like that. So that's how you do, there's a lot of different applications for this, but that's how you find increasing and decreasing, maxes and mins on a function given the derivative of that function. Okay, we can also find out some information on this using the second derivative. So the first derivative, remember, gives us a slope. The second derivative gives us what I call the acceleration. Using physics terms, the second derivative of a function gives the acceleration. So it tells you whether the slope is increasing or the slope is decreasing. So is the function may be increasing or decreasing, but is it increasing or decreasing at a faster or slower rate? So what we can do with that in the original function is going to look like concavity. So it could be an increasing slope, but it could be slowing down like that. Or it could be an increasing slope, but the slope's actually getting bigger and bigger like that. This one would be concave down, and this one would be concave up. Same thing with decreasing. We can have functions that are going like that or like that. Both have negative slopes through these intervals, but one is becoming more negative and one of them is becoming less negative. Okay, so concavity here we can determine by the second derivative. And same thing, we have these intervals marked out, and we need to look up and see, plug in a value here in this interval. So say pi over 8, anything in here, or you know, here we could do pi over 2, and find out whether it's positive or negative. So the first value, this one is going to be negative. If I plugged in pi over 8 or any number in this interval, I will get a negative. So just use your calculator, plug it in, and see what you get. And again, these are going to alternate. They don't always alternate in this case. A function could be going up and then going up again. So you could have plus and then plus with the interval. But anyway, in this case, because it's a sine function, these are going to alternate. Now here, and so that'll show your concavity. So again, looking back at our other previous lesson, we can determine the slope increasing or decreasing, but then we can also figure out the concavity. So say it was, I think I remember the function before, it was decreasing from 0 to pi over 2. So it's going down and it's concave down from 0 to pi over 4, but then after pi over 4, the function is still going down, but it's not going down as fast. It's now concave up. So these points, though, where the concavity changes are called points of inflection. And I can find these points of inflection by setting the second derivative equal to 0 and solving for where this function will be 0. And we did that before, and those points are pi over 4, 3 pi, 5 pi over 4, 7 pi over 4, and 2 pi. These are points of inflection. They're points where the concavity will change. So that is useful things you can do with the first and second derivative. If you liked today's video, give us a thumbs up and like our channel, subscribe to our channel, and we will see you next time.